Hey everyone, thank you for checking out another video. This tutorial is going to be about how to make these cool little minimalist planets. It should be a pretty quick one, but hopefully you'll have fun. I've got a little bit of the processing code set up already. Just the three colors that we'll be using. This is the planet field color, the outline color, and the background color. And then I've got my setup function here. So we can add the skeleton for our draw planet. We're going to pass in a position and a planet size. I'm not sure if I've shown this function in a tutorial in the past, but instead of drawing our planet at the position, we're actually going to translate our canvas to whatever position we pass in, and then we'll be able to just draw at our origin point. We're just shifting the origin to our position. So translate position 0, position 1. We'll say add background. I don't really know how to call these. We're essentially just going to add a circle at planet size. Then we're going to add the rings. Add rings. Cover rings. And I'll show you what that means in just a second. We can go ahead and run this. Draw planet. So our width and height, we can just say width divided by 2, height divided by 2. And for planet size, we'll say 200. So we're drawing a circle. It's the basis of our planet. We can go ahead and add two more variables that we're going to need. Planet width equals, we'll say 6, and then ring width equals 6 as well for now. Those are just going to be the stroke widths. We're going to want maybe different values for those depending on whether we're drawing the planet or the rings. So before we draw the background of the planet, we need to set the stroke weight to planet width. And we also need to make sure that we're filling it with the planet fill color. So that should be everything we need for the background. We can run this again to see that the stroke width has changed. For the rings, we're actually going to draw a series of ellipses in front of the planet, and then we'll cover up part of them to make it look like the rings are going behind the planet. So we do need to say no fill because we're going to be drawing them in front of the planet. Stroke weight, ring weight, or ring width. I guess it was weight the whole time. Then we'll just say for I in range, int random. This is up to you. I'm going to do 3 through 9. So we're going to draw between 3 and 9 rings. Then we use the ellipse function. Remember, we've translated to our position, so we can just say 0, 0. This would essentially be the center of the ellipse. And then I'm going to put in arbitrary values for now. So let's say 50 and 200. But we're going to change that in just a second. Now that's only one ellipse right now. And we've set the ellipse width, I guess you can think about it. This width up and down. Now it's the Eye of Sauron apparently. 200, it's the same size as our planet. So if we make that 400, you'll see that it kind of goes out and beyond. And we're drawing all of these at the same position, and we're not adjusting the size, and that's why you only see one ring. So if we want the rings to progressively get larger to simulate multiple rings surrounding the planet, we need a starting height and a starting width. Starting height. I start with a random size, and that's between planet size divided by 4, planet size divided by 2. So there's a little bit of a range for the starting height, and that'll be the obviously the smaller value. Starting width. Same thing, we're generating it in a range, but it's going to be larger than the planet size, because this is the part that definitely needs to be larger than the planet. In this loop, we can use the fact that we're iterating over a range to adjust these values. Starting height plus I times 10. Every iteration, then we're increasing the height by 10. Starting width, we're going to do the same thing for width, except the value that we're increasing it by will be larger. So if we try this, that looks a lot better. Now all we have to do is cover up one side of these, and it'll look like the rings are actually going behind the planet. We're going to reset the stroke weight back to the planet weight or planet width. Set the fill back to the planet fill color, just in case. Well, actually not just in case, we have to do that. Now we're going to use a function called arc. We're just going to draw part of a circle. 0, 0 again. We call planet size and then planet size again. And this part's a little interesting. 1.5 times pi, 2.5 times pi. And this should work. Yeah, it works perfectly. And it'll be a little bit easier to see. Let me actually change this. 255, 255. So we'll set it to a different color. Now you can see exactly what we're doing. We're basically just drawing this half circle just so that we get rid of the rings. If the rings extend past the top of the planet, then we don't care. We don't have to cover that because you would be looking at it over the planet's horizon or rim. So we can change that back to the color. So we have our planet. The last thing we have to do, if I run this multiple times, the only thing that's going to change is the size and number of the rings. We also want to rotate the planet. The only thing we have to do is call rotate, random, and you can say, I guess, 2 times pi. We can run this, and now the planet's going to be at a random orientation. Since we're rotating at the beginning, we're drawing all of the rings at this rotation, and we're also putting the arc at this rotation. The rotation is the primary reason that we needed to translate at the very beginning, because we are rotating around the origin. Now if you want to see this on an endless loop, we can just put draw planet inside of a draw function. And then we also want to make sure we're drawing the background every time. So background color, background color, background color. Now if I run this, I hope this has been a fun video. If you learned something new, remember to hit the subscribe button. Leave me a comment about what you'd like to see in the future, and hopefully I will see you in the next video. Thank you.